Hello, Uggies worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're continuing our review of items from Ham Radio Boutique. This right here is a 49-to-1 Balun that they made. So obviously that's an end-fed antenna to 1.8 to 30 megahertz up to a kilowatt, according to this. Part number Echo Foxtrot 14349 Tango 1. Okay, now this is from hamradioboutique.com, Boutique. Okay, Ham Radio Boutique, all one word. Now, there's a problem with this particular one. Let's take a look. I heard something rattling. That didn't sound good. So I took the top off, and what is rattling in there is the coil. You see where it was glued to the side here? The glue kind of stuck to the coil, but it definitely, silicone probably, did not stick to that inner surface there at all. It completely comes off, okay? And then down here they've got another bunch of glue which hasn't been disturbed. Now there are a couple anomalies here. First, this right here has to be resoldered to this. That's where it needs to go. And then, weirdly, here's a capacitor right here. There's only the slightest little piece of solder on here. It should have been soldered over to here. And this will be soldered here. And then this wire here was not hooked to anything. Doesn't even have the insulation stripped off of it. And again, this came off of the bottom here. This is definitely the wrong kind of goop. This needs to have its threads shined up and also glued over or soldered over to here. And then this right here is the counterpoise wire. Or you can skip that and just use the outer shield of the coax as the counterpoise, but make sure that you've got that grounded before it goes into the shack, so none of that extra radiation goes in. Now here's the antenna. This is the part that's the long wire. They've provided a crimp connector here. I would recommend that if you put this in for your wire, you crimp it and then solder it so that one doesn't pull out. Now this is designed right here to fit over the top element of the mast. And these are wing nuts here where you can loosen this a little bit and slip that over the mast and then tighten it on. That was the Type 7 mast that we reviewed very recently. Okay. Another thing you can do is unscrew that from that mount and just hang the rope through that hole right there and then let the wire antenna go out there, which I think is what we're going to try to do. So I'm going to have to fix this. It won't be too hard. Just need a soldering iron and a little patience. But I do need to get that cleaned off there so that it will glue over here to the ground. This will glue over here to the ground. That's a capacitor. And then this will glue, and then this will glue to the incoming right here. So I'll get that fixed up, and then we'll test that. He's only got a 2 to 14 turns ratio. Now that might work well on the other bands, but I'm not sure how well it's going to work on 80 meters. I don't have enough room to put in 160 meter wire. Okay, so we will do that and come right back to it. The model number of this one is the Echo Foxtrot 14349 Tango 1. Okay, now the reason I have just this off of it is because it came apart, as you can see from this video we shot yesterday. So what I did, as you saw yesterday, this wire was completely disconnected. This is the wire that's the return for the primary winding on this transformer. This wire right here that goes over to the ground was connected only to ground. This capacitor was connected to the center pin here, but was not connected to anything here. So I went in and fixed that. I also found that the goop that is in here doesn't really stick to this at all. It just peels right off. And so I've got to find something else to do that. I've got some Gorilla Glue somewhere. I'll try that. But the problem is that the silicone stuff he was using does not attach to this. I mean, it seems to. See, we've got some up here that seems to. But if we just pull it like that, it just comes right off. It's not really attached to the side. So that's something that the manufacturer can easily fix. Okay, so having put this thing back together, the next thing we have to do is test it to see if what we did. Now this is a 49-to-1 Balun. Okay, so 50 ohms in, and it's 49-to-1. Well, 50 times 50 is 2,500. So 50 times 49 is, you take 25, it's 2250 out. Okay, ohms. Now this resistor right here is a 2200 ohm resistor. So the way this works, if this is doing its job, you should see a 1-to-1 SWR close to, this isn't exactly 2250 ohms, but close to when we connect this up in here. I want to show you the schematic so we can see what we're looking at. Now this is kind of backwards, because usually you put the generator over here. But what we have is a Nano VNA, Vector Network Analyzer, and we're coming into this thing. And what we have on this core right here, we'll demonstrate the core this way. This comes 1, 2 laps through. You see that this right here goes around twice. You count the number of turns by the number that actually go through the toroid. Okay, so there's 1, 2, and then it comes off over here. Okay, so what we have is this is right here. This comes back over here, and this is actually ground in a real scenario. And then we have the secondary winding, which is 14 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 turns. Okay, so this is 1, 2, 3, 4, and then 14. We'll just mark that 14. And this is 3. So I'm sorry, 2. This is 2. It goes through twice right there. Now, so the turns ratio is 14 divided by 2 equals 7. Now that gives you the voltage, okay, but as the voltage goes up, the current goes down by the same factor. And so if you want to get the same power out, what you're going to end up is with a, whenever you do a Balun, the actual ohms ratio is the turns ratio squared. That's 49. 7 times 7 is 49, okay? So we've got a 49-to-1 Balun here. So if this is 50 ohms, what is the resistance here? 50 times 49, which is 2250 ohms right there. So if I put a resistor across here that is 2250 ohms, I should get a 1-to-1 SWR when I put 50 ohms here. So that's what the Nano VNA does. Gives us our 50, gives us our 2250, and if this were a different resistance, we would get a higher SWR. It will match perfectly when it's 2250 ohms. Actually, 2200 ohms is a standard value for a resistor. Now, I will grant you that this right here is only a 1/4 watt or less resistor, but we're dealing with very, very small amounts of power here, so I'm not going to blow that up. So what I'm going to do is connect that resistor, which is to the hot output of the 49-to-1 Balun, actually an unon, and I'll connect this over here to ground. And we'll take a measurement. This is connected to the computer, and in the computer I have a piece of software called the Nano VNA Saver. Okay, and they're constantly updating this. I happen to have 4 different plots. This is SWR, this is the Smith chart, These right here, the blue line is the reactive axis, and the green line is the resistive axis. 50 ohms is right up here. Okay, so it gets fairly close. Now note right here we have a 0 on the reactance. Right there, where the reactance is 0, is where the thing is actually resonant. Okay, and that actually works out to about 8 megahertz, something like that. But now I want you to look at the SWR. On 160 meters, it's 2 to 1. On 80 meters, it's about 1.5 to 1. Here's the 60 meter band, the 40 meter band. This very tiny red line is the 30 meter band. Here's the 20 meter band, 17, 15, 12, and 10 meters. Okay, so yeah, it's kind of doing things where you're getting some of the good response from reactance. Up here it's inductive, down here it's capacitive. And this right here is the return loss. We lose the most signal, 40 dB here, and up here it's about 26 dB, both of which, and in here it's still enough that the amount of reflected power is quite low, which we see right in here. Okay, so this can be used as the 49 to 1 Balun without introducing too much of any kind of effect. So what we've shown here is that this Balun could easily be repaired, although I was a little surprised to see that the manufacturer left the grounded side of the primary winding unconnected to anything, and also I think the capacitor, which was not connected to anything, had a little tiny bit of solder on one side, so it was probably tacked to the correct lead at the time. So I used a little sandpaper to get the shellac off of the magnet wire and hooked that in through. I used a solder sucker to pull all the solder off of the ground lug on the SO239, hooked it through there so I'd have a good mechanical connection. This is a point that all the soldering courses teach you, is that you really need to have not only a good solder connection, but a good mechanical connection, so that if you're trying to modify it or remove the solder or whatever, you have a solid mechanical connection as well. And then that way, if there's any kind of movement on the device, you've got that mechanical connection to keep it in place. So this thing's ready to go. We know it works, we've tested it. Now in the next video, we are going to actually construct an antenna for this, and we're going to put it up on the mast. So until we next meet, well, we'll finish out this little series, 73.